Myself, Dr. Niranjan R.S., Assistant Professor, Department of Physics, Government First Grade College for Women, Chipra. Now I am going to discuss the topic quantum confinement in 2 dimension, which comes under the unit nanoscale systems. Particle trapped in 2 dimension. Example for this is nano sheet. In nano sheets, carriers are allowed to move along 2-dimensional space or 2-dimensional plane. The pictorial representation of nano sheet is here. It is a 2-dimensional space. Particles can move along x and y directions and freely, but it is confined along z direction because of a very small thickness along the z direction. Its thickness is small t. If we consider particle inside a 2-dimension, carriers means electrons or holes are confined in 1 dimension, that is along the z direction, and the particles are allowed to move freely along the x and y directions. In nanoparticles, this is the case of nanosheets, where carriers are allowed to move along the 2-dimension plane. In this case, the wave function and the energy we can calculate by solving the Schrödinger wave equation. By solving the Schrödinger wave equation for a 2-dimensional trapped particle, the wave function is psi n xyz equals 2 by t to the power of half sine of nx pi z by t e to the power of I kxx and e to the power of I ky y. This is the wave function we obtained by solving the Schrödinger wave equation in case of particle which is trapped in 2 dimension, where the value of nz is called subband index, and for n is equal to 1, the carrier is assumed to be in the first subband. If we look into the energy eigenvalues is obtained once again by solving the second order Schrödinger wave equation for a particle which is trapped in 2D. We obtain the eigenvalues, that is En equals h square over 2mt square nz square plus h square kx square over 2m plus h square ky square over 2m. These are the eigenvalues. By substituting the value of 0, 1, 2, 3, etc., we will get the energy eigenvalues. In general, the electron motion in a semiconductor band is described by introducing the effective mass of the electrons and holes. The example for particle trapped in a 2-dimension is standing waves are formed by scattered electrons inside a ring of iron atoms on a copper surface is the example for the particle trapped in a 2-dimension. These are the information we obtained from the references which are mentioned here. Thank you.